Hi, I'm Alicia Mirienko, and here are my two capstone projects for Python class CtD. For the first project, I decided to work on a raw and complex dataset from Global Superstore, and I turned it into a structured analysis project. I focused on data cleaning, feature engineering, data aggregation, and data visualization. Throughout the process, I standardized and converted data to correct data types. I engineered features like customer type, new and returning customers, and divided the profits and discounts into different levels. I also built modular aggregation functions for flexible analysis. I designed interactive visualizations using Plotly and Seaborn to communicate insights. Before I start working on aggregations, feature engineering, and data visualization, I decided on key metrics that I need to use for my visualization. Here are some of them. Top profitable states and product subcategories, sales and profit distribution among categories and subcategories of products per country, monthly sales versus profit, active customers quantity over time statistics, customer segment valuability, and market correlation. Profit and discount correlation, monthly minimum, maximum, and average sales on US markets per chosen year. Here are some of features I engineered. I pulled the months from the date, from the order date, discretized profits into buckets, start from negative, then zero, low, medium, and here the discount discretization. I defined the customers as new and returned customers based on the first order they placed. Summarize states total profits and subcategories by total profits. Customer lifetime value. Monthly total, minimum, maximum, and average sales on US market. Here's the visualized data. The the horizontal bar chart for top 10 states by profit. 5 subcategories. Here's the sunburst chart for sales distribution. You can see for different categories separately. And here's the profit distribution, and here's the sales distribution. Here's the comparison, expenses versus profit. Here are the customers starting from 2011. Customer segment valuability and market correlation heat map. Profit and discount correlation. Monthly sales statistics. Some key takeaways on this project includes understanding how a discount impacts profit, identifying top-performing products and regions, calculating customer lifetime value using real transactional data. This project helped me strengthen my skills in data wrangling, explorative data analysis, and business-focused storytelling with code. Here's my second capstone project for Python class at CtD. For this project, I built full data pipeline and interactive dashboards to explore Major League Baseball statistics from 2021 to 2024. I wanted to create something end-to-end that brought raw data to life and helped answer the real questions, like who were the top players and how do different leagues perform over time. Here's how I did it. Step one was a web scraping. I started by collecting statistics from multiple pages using Python, Selenium, and Beautiful Soup. This involved automating the browser to visit different pages, extract statistics, and collect data for further processing. Also, during this first step, I cleaned and normalized data to import it into a database. Step 2. Importing data into a database. I imported cleaned and normalized data into an SQL database. I designed proper tables like players, teams, years, statistics, and linked them together using SQL Alchemy, which allowed me to work with the data more efficiently. Step 3. Querying the database. Using SQL queries inside Python, I retrieved specific combinations of statistics, player performance, and league year breakdowns. I also built dynamic functions to populate filters like years and statistic groups automatically. Step 4. Interactive dashboard with Streamlit. Finally, I built a full-featured interactive dashboard using Streamlit and Plotly, where users can where users can filter players by league, statistics category, or choose the specific statistics that bind to the statistics category. For example, for hitting statistics, it will be different list of statistics available. Here's a bar chart for one chosen league, and here is the line chart comparing two different leagues. You also can take a look at the best players. Here are the best players per specific statistics. You also can choose the league, pitching or hitting statistics, and specific statistics. That shows all the best players during those years, 2021 through 2024. They're ranked based on the results. And here are the best players per team during all those years. For the best players, we can choose how many times the certain players will be the best during those years. This project helped me to connect Python programming, SQL databases, and data storytelling in the Geyser tool. It is not just about the code, it's about creating something people can use to explore and find insights on their own. Thank you. I'm excited to share this with you and hear your feedback.